Good evening, everyone. We are here today to introduce you to Project Sayyara, an all-in-one solution for arranging automotive repair for both the client and the repair shop. We are working together on this project with our partner, Nabil Ibrahim, who envisioned the idea behind Sayyara and provided us with written feature specifications. Following his design, we built the application from scratch. Now, let us put ourselves in a situation I'm sure many of you have encountered before. Your vehicle has broken down and you need to repair it as soon as possible. What are the options for a price-conscious vehicle owner? A common course of action is to pull out your phone, search car repair shops near me, and start calling each shop that appears. This often involves listening to a robot slowly rattle off options, pressing numbers, and then sitting on hold. If you manage to get a person on the line, you have to verbally explain your issue as well as list off your car details, likely having to repeat yourself. Only after repeating this grueling process many times can you compare all the quotes you received and select the cheapest option. No one enjoys this process, and before you know it, your entire afternoon is gone. Sayyara aims to centralize and streamline the automotive repair process, acting as your hub for arranging vehicle repair. Without ever leaving the app, the user can browse repair shops and view their services, request quotes for their issue from any participating shop, and monitor the status of their quotes and easily compare price estimates. Afterwards, the user can directly schedule an appointment with their chosen shop. The customer isn't the only one who benefits, though. The shop owner also sees several advantages to using Sayyara. By creating an account, shop owners can see their upcoming appointments with relevant information available at a glance. They can see quote requests and reply with a price at their earliest convenience, removing the need to be available to answer the phone. Now, my teammate Hamoon will take you through a demo of the application in its current state.
In this demo, we're going to go through the flow of two users, the vehicle owner and the shop owner. So we're going to start off as a vehicle owner and we're going to send a quote for a specific service to a shop owner. We're going to then send back a price for this quote as a shop owner to the vehicle owner. And then the vehicle owner is going to accept this price and turn the quote into an appointment. So starting off, this is a vehicle owner's homepage where we can see a view of all the shops on Sayyara. So here we can search up by any of these fields like province or city, address, etc. So for this demo, let's request a quote from Jane's Auto Shop. So here, the only service provided by Jane's Auto Shop that requires a quote is brake inspection, since it does not have a fixed price. So let's send a quote for a brake inspection for our car. So let's just say we go here, select our vehicle, let's just say BMW M6, paste in the VIN number, put in our license plate, and select brake inspection, which again is the only service here that does not require a fixed, or that does not have a fixed price. So here we can say providing some notes. Here you can put in any extra notes that you want to send to the vehicle owner, and we can submit this quote. So now we've sent this quote to Jane. A quick note though, since vehicle owner accounts were not scoped into our MVP, the system now assumes that you're going to use the same email and the same car for any future quotes and appointments, as it just wasn't in our scope to handle login and sign up for vehicle owners. So here we can see that we have a quote for a brake inspection from Jane's shop. So let's log into Jane's shop and check out our quote. So here we're on the home page. We can just get a quick view of all our appointments, but we don't have any in the next week, so we can check here quote requests. We have all our quotes visible here right now, and one of them that requires our attention. So this quote, the BMW M6 brake inspection, is our newest quote that requires us to send back a price. Here we can also see the status as well, and all our quotes in this table where it's pending my review to send back a price. So this pop-up is going to be the same one that shows up on the home page. So we can just click here and select the price. So let's just say the brake inspection is going to cost $62 or $64 for the BMW M6. I'm going to send that back to our vehicle owner. I'm going to log out of this Jane Jones shop and then go check out my quotes. Now I see that my brake inspection is pending my approval. So when I click here, I see that the price that's been quoted to me is $64. If I think this is a fair price, and I remember all the information about the shop here that was given, all the details about the quote, I can say, okay, I want to turn this into an appointment at 9 a.m. on Saturday. I like this price. I want to create an appointment. So now this quote has been accepted, and the details are still here from the quote. And if I go to my appointments, now I see that Jane's Auto Shop has my appointment tomorrow for 9 o'clock. We see it's $64, the BMW M6, and all the information about the shop that was given earlier. So we can log back into Jane's shop and see that Hamoon Zamiri has a appointment tomorrow. We can click on it to get the same quick view of the details about the appointment here. And we can also go to our tabular view of appointments, see that Hamoon again has a brake inspection tomorrow, 9 to 9:30. And we have all the details here that were there before. So that's the end of the first flow, just some additional features that we wanted to show off. So for shop owners, we have this quick and easy screen to manage the services that our shop provides. Let's just say I don't provide oil change anymore. I can delete it. I can then add a new service here and provide a price for it, like $23. It's going to show up here immediately. It's quick and easy, delete and go. And we also just wanted to show that we have the basics for changing your password, editing your profile as a shop owner, and all that stuff. So that's it for the demo.
Now that you've seen a demo of the Sayyara website that's available for public use, I want to show another website that acts as our internal documentation from the backend team and is available to view at this URL. We utilize Swagger to allow the backend team to provide documentation that will benefit the frontend team, which saves a lot of time in communication and discussion and allows us to focus more on development. At the top of this page, we put info about how our JWT authentication is set up in the backend, and for each endpoint below, there's a little lock that shows which endpoint is protected. We also have credentials for some preset mock data available to log in as a shop owner and test the application. All endpoints are grouped by a category, and you can click on any endpoint to get more info. For example, to update a quote with a new price or status, you can open up this patch endpoint and view additional details. Here, it tells you what values you can pass in as a status. We can also see the parameters, the request body, and all possible responses with values that they'll return. Each endpoint dropdown contains all of this information. If we scroll down to the bottom, we also have all the schemas for objects that we used, and you can click on any of them to view additional details on the fields. All details for this page were written manually, which was a time-consuming process, but in the end paid off with the amount of time and effort that is saved, and it will continue to do so in the future of this project as well. Now, let's discuss the technologies we use to build this application. I'm going to do this by showing a couple of diagrams that show our application architecture. These will also greatly benefit the next developers that we hand off this project to. Before we get into those, I want to start off by discussing the languages and frameworks that we used. We used TypeScript in the front end and Java in the back end, and we paired those with frameworks that we thought would handle a lot of the infrastructure work for us so that we could focus our attention on building out the core features. For example, Tailwind CSS made writing CSS a lot easier, and using Spring in the backend made it extremely quick to set up our API endpoints. Moving on, here's a key diagram that shows our end-to-end workflow from the user on the left accessing the website, all the way to how the data is saved and retrieved from the database at the bottom right. It starts off with the router catching the route from the URL and rendering the corresponding component for it. Then, we utilize React hooks to abstract making HTTP requests through the Fetch API in TypeScript, which would get caught by the backend's controllers. These controllers send the parse data to the service, which then accesses the repository that makes database operations with PostgreSQL on the entities. Overall, it's a pretty streamlined process that runs in a one-way dependency that makes it really easy to follow along, as well as extend and maintain. Diving into the front end, this diagram shows all of our React files and the folder structure that they're in. These are the three main sections taken from the diagram. We split it up into pages, components, and utilities, with clear distinction between what goes where. This helps give a bird's eye view of the front-end architecture, as well as again shows the direction of flow, where we start from the left at pages and depend towards the right. For the backend, we chose to package by layers, which you can see on the left. By separating it into packages like this, it again makes it easy to see the flow of the classes by depending towards that direction you can see with the 4 packages on the right. Next, we have our database tables. This diagram helped us out a lot during early stages of development. It clearly shows each entity and the fields associated to it, as well as how they're linked and connected together. This also helped the front-end team a lot see what types they need to define for the entities. And finally, I want to emphasize that throughout this project, we tried to put a lot of attention into writing clean code so that this project can be easily maintained and extended. Both of these code samples deal with the authorization of HTTP requests in the front end and back end and abstract the logic of it. If we ever need to update or change the authorization method that we're using, very little code would need to be modified since most of the project depends on this code, which makes it very easy to maintain. Overall, we're proud of the architecture we've come up with and believe this will make it significantly easier for new developers to continue building this project.
For accessing the application, we've discussed with our project partner and decided that the best approach will be to give him access to the GitHub repo containing our application's code. Since the current repo is in the university system, we're planning to fork the repo once we're done and give the project partner access to it. In addition, we're also going to provide links to the deployed version of our app. Right now, the front end of our application is hosted on Vercel, while the back end is on Railway. The links here are for the deployed application and are going to be provided to the project manager. We've also set up integration between Vercel and Railway so that Vercel deployment can have access to the Railway environment if needed. As mentioned before, Railway contains the backend and database deployments while Vercel contains the front-end deployment. Continuous integration and continuous delivery and deployment is set up through GitHub Actions to automatically deploy to both of them when pushing to the main branch. This makes it easy to make changes and not have to worry about manually deploying. When testing in the local environment, Docker is used to run the backend and the database, while npm is used to run the front end. We have an email that's connected to the deployed backend and front end on Railway and Vercel. Once you provide the account details for this email to the partner, they can access the deployment and configure it however they want. There is also a GitHub account that's made for the partner which has access to the repository code. The repo is also going to contain documentation which will contain information on how to run the application locally. The documentation will also explain the software architecture and tech stack of the app, list the features that were completed alongside all the features the project manager eventually wants, what the next features to implement should be, and also the steps that would be needed to be taken to make further updates and changes to the application.
Next up, our key learnings. Overall, our team is very happy with how our project went. However, there are a few things we wish we had done differently. First, we sacrificed designing detailed mockups in favor of starting development as soon as possible. But later on, we had challenges with producing a cohesive front end because we lacked a clear blueprint for what each page would look like and how separately developed features would interface. Secondly, we didn't put enough effort into mapping out the sequence in which we would handle our tasks. Without that roadmap, we unsurprisingly ran into roadblocks where a feature was delayed or had to be refactored because we didn't realize it was dependent on another yet to be started task. Lastly, we didn't define a clear agenda for our stand-up meetings. As a result, our meetings often turned into lengthy debugging sessions without a clear goal or end in mind. Ultimately, we found that these shortcomings all compounded on each other. If we could do it again, we'd allocate more time to designing thoughtful mockups prior to development. These mockups would have helped us anticipate feature dependencies, so we could use tools like a Gantt chart to avoid development bottlenecks. Additionally, we would allocate separate time in our meetings for progress updates, for problem solving, and for next step planning. With more deliberate meetings, we'd have more time as a team to identify and address process issues like the ones I've just discussed. Finally, the teaching staff could have better supported us if, for example, our TA had taken a more active role in our tutorial meetings. Instead of just asking if we had any problems at that time, our TA could have led the discussion and asked us, "What are your recent developments and why did you make those decisions?" We're often unaware of our own mistakes, so a more proactive approach from the TA would have really helped. And that concludes our video. Our team has had an amazing journey throughout the semester, and we're very proud of the end result. On behalf of my team and I, thank you for listening.